sequence and to observe lead. In this work, we intend to provide. In this work, we intend to provide a sequence-based attack detection mechanism, especially for finding the sequential attack patterns. This is our outline. And first, I will introduce the full background of this work, and then we given some problem definitions. Then we used our SBAD to solve these both proposed problems, and then we use experiments to verify our result. Finally, we get the conclusion. Actually, sometimes this is a sequence of attack. You can see there has it's triggered by the intrusion detections, and it's a sequence of attacks and present the multi-step attacks. And it's come with the timestamp and the labels. And how we find this long string of events and automatic and SBAD attacks inside in the string. Also, in another application is from the web application. Sometimes up to now there has many process script or sequence injections based on the web script. And how we identify the sequence of the script. So in our work, we tokenize this sequence of script as a tokens and find the token sequence. And either this is a table or not. So the main purpose is we want to spot the text in automatic way. Our proposed SBAD include three characteristics. The first one, we spot frequent group of alert and HTTP tokens, and then we summarize them into a suspicious sequence of activities. We can group them because we calculate the similarity for each sequence, and then we can visualize them. So this is one example for the visualized result. You can see in PKDD 07 dataset, there has 8 kind of classes, and 7 is malicious attacks, and 1 is benign. And we use our method. We hope to easy to separate the attacks and the normal behavior benign. Actually, it is not a straightforward way because. Okay, so first I mentioned that our major behavior event is the sequence pattern. And there are 3 challenges for spotting attacks from real case of S07 is a data set we collected from the real environment. This data set is we collected from the Acer Electronic Data Center. They want to monitor every organization as a security operation center's data. So in this data set, we observed 3 different challenges. The first one is variation. For example, given A, B, C, B is a pattern, and sometimes some pattern has repeated happen. However, these 2 sequences are equivalent because some actions are interactive, repeated trying. And then we have second challenge is interjection, because even when we given A, B, C, B, and sometimes some consecutive patterns and meaningless were injected into our original patterns. How we elevate this kind of impact. The third thing is the interleaving. Actually, some attacks or behavior were happened and were interleaved with each other. So how we elevate this kind of things. So this work's contribution is propose a number of similarity measures. It can handle the noise. Noise means variation for the behavior sequence, and the interjection, especially for long insertion. Okay, and the interleaving to attack behavior sequence come together. Also, we provide a visualization mechanism. Okay, now I start to define some problem in this work. The first problem is how we identify the attacks from the event sequence. Actually, this is our key problem. And we use following problem when we solve the problem 2, 3, 4, and we turn to solve the problem 1. And the problem 2 is we use a graph use a graphic-like structure to generate the attack graphs, and then we try to coding the sequence by the generated graphs. And finally, we use sequence discriminating measures to elevate above the mentioned challenges and find the appropriate discriminating score. Okay, the problem was when we get these alerts, alert sequence or event sequence, and with labels, we can generate the graph correspond this sequence. And then when we give an incoming sequence, we want to know this sequence belongs to truly a text or false alarm, or is a benign or malicious. So given a string of events with ground truth and a set of non-attack graphs, which alert belong to the same sequence attack and give the attack. And also we want to know that this attack sequence belongs to which attacks graphs. So we use the second problem is from the first problem is how we generate the graph. So we use marker model, and I will mention later, and find the graph G. And we hope the graph G has the best describe the sequence for the sequence. And the third problem is how we do the sequence coding. We use and in the trickiest way. So for example, when we given the sequence and a model, this model is have a different status with the probabilities, and how we find the appropriate coding, we use the likelihood. I will mention later. Finally, when we give two sequences, how we get the dissimilarity between these two sequences, whether maybe this is a true text, this is a benign, we hope they have a longer distance. Okay, our solution. And so I first try to solve the problem 2, and solve the problem 3, and solve the problem 4, and finally we can solve the problem 1. So we give an event sequence, and we can say behavior sequence or alert sequence or a script token sequence, and we give a correlation window size, and this correlation window size, the number of the correlation window size we have analysis later. Actually, this size is robust for every data set, and we want to correlate the approximate relations for the incoming sequence. Also, we try to use scenario windows. Scenario windows depend on different environment to the different setting. For example, this system provided to the Taiwan's internet service provider. The network is very the network workflow is very large. So they huge. So the scenario window size they tune less. So actually, the scenario window size must be identified by the heuristic. However, correlation window size you can identify is not have an impact. However, this have another problem is how we count these transitions. Actually, someone used the Bayes relation to count the approximate relations. However, in our work, we found several things that if we give an A, B, B, C patterns, and maybe some noise or the random noise will insert into between tokens or events. So how we elevate this impact? So we try to use the all pairs, the relations, and because this insert randomly, so even we count the AC is a noise, it would not have the large count, then will not impact the original pattern we want, AB. So we try to use this simple counting mechanism to solve this problem. And then how we do the sequence coding? Actually, we use the local likelihood and given a sequence, and we want to see how these models describe this sequence. finally, how we this is a critical part for this study, and we given two event sequence E1 and E2 and associated G1 and G2. How we determine the distance between E1 and E2. So we try to use the minimum description length concept to use our previous generated G2. G2 is generated from the sequence E1 to describe the E1. And we use G1 to describe the E2. And this is the normalization. We calculate these two sequences and generate another model to describe the distance. Okay, I use a figure to show this formula. Even we give E1 is like this sequence and the E2 sequence. E2 generate a graph, and we use this graph to describe the E1, and we use E1 sequence and generate a model to describe G2. However, if we do not have this formula, we will impacted by the length of the sequence. So we use this to do the normalization. Okay, so this is correspond to this corresponds to, and this is the dimension. Okay, based on the above mentioned, we try to evaluate our method, and we have 4 parts of the experiment. The first one is we do the sensitivity analysis for the correlation windows. The second, we analyze the impact of the all pairs, whether the all pairs is helpful or not. Then we try to analyze the effectiveness of our proposed method compared with the other current approaches. And then we try to see if the visualization makes sense or not.